Conservation of mass. Understanding what really happens during a chemical reaction. Before you learn about the law of conservation of mass, it is important to understand what actually happens during a chemical reaction. Many students imagine that substances disappear and new substances suddenly appear. This is not what happens. In reality, every substance is made of tiny particles called atoms. Atoms are the basic building blocks of all elements. During a chemical reaction, these atoms are never destroyed and no new atoms are created. Instead, they simply separate from one arrangement and join together in a new arrangement. Imagine you have a box of colored building blocks. You can take the model apart and build something completely different, but you still have exactly the same number of blocks. None of the blocks disappear, and you do not magically create extra ones. Chemical reactions work in exactly the same way. The atoms are like the building blocks. They are simply rearranged to make different substances. This idea is one of the most important principles in chemistry. Once you understand it, balancing equations and calculating masses become much easier. The law of conservation of mass. The law of conservation of mass states that during a chemical reaction, no atoms are created and no atoms are destroyed. Because the number of atoms stays exactly the same, the total mass also stays exactly the same. This means that the total mass of all the reactants before the reaction is always equal to the total mass of all the products after the reaction. Reactants are the substances that are present before the reaction starts. Products are the new substances that are formed after the reaction has finished. Although the substances may look completely different after the reaction, the total mass never changes. For example, magnesium is a shiny gray metal. Oxygen is a colorless gas. When magnesium burns in oxygen, a white powder called magnesium oxide is produced. The product looks completely different from both reactants, but every magnesium atom and every oxygen atom that existed before the reaction is still present afterwards. They have simply joined together in a different way. Why does mass stay the same? Mass stays the same because atoms stay the same. An atom cannot simply disappear during an ordinary chemical reaction. An atom cannot suddenly appear from nowhere. The atoms only break old chemical bonds and form new chemical bonds. Think about a group of people changing seats in a classroom. At the beginning of the lesson, there are 30 students. Everyone stands up and changes seats. When they finish moving, there are still 30 students. Nobody has disappeared. Nobody new has entered the room. Only their positions have changed. Atoms behave in the same way during chemical reactions. A very important rule. Always remember this sentence because it appears in many GCSE examinations. The total mass of the reactants is always equal to the total mass of the products. You should be able to explain why this happens. It happens because atoms are only rearranged. No atoms are created. No atoms are destroyed. Looking at a simple reaction. Magnesium reacts with oxygen to form magnesium oxide. Before the reaction, there are magnesium atoms and oxygen atoms. During the reaction, the atoms collide with each other. Old bonds break. New bonds form. At the end of the reaction, every magnesium atom has joined with an oxygen atom. Nothing has been lost. Nothing has been added. Everything has simply been rearranged. This is why chemists say that mass is conserved. What does conserved mean? The word conserved means kept the same. When chemists say that mass is conserved, they mean that the total amount of mass does not change during the reaction. The substances may change. Their colors may change. Their temperature may change. Their state may change from solid to liquid or from liquid to gas. However, the total mass always remains the same. Why is this law so important? The law of conservation of mass helps chemists in many different ways. It allows scientists to predict how much product will be made during a reaction. It helps chemists calculate how much of each reactant is needed. It allows chemical equations to be balanced correctly. It helps explain why reactions behave in the way they do. Without this law, chemistry would not make sense because atoms would appear or disappear without explanation.
A common misunderstanding. Many students think that because a reaction produces something new, extra atoms must have been created. This is not true. For example, hydrogen and oxygen react to make water. Water looks completely different from hydrogen gas and oxygen gas. However, every hydrogen atom in the water came from the hydrogen gas. Every oxygen atom in the water came from the oxygen gas. No extra atoms were created. The atoms simply joined together in a new arrangement. Another everyday example. Imagine you have 10 Lego bricks. You build a small house. Later, you take the house apart and build a car. The car looks different from the house. However, you still have exactly 10 Lego bricks. You did not lose any bricks. You did not create any extra bricks. Chemical reactions work in the same way. Atoms are rearranged, but the total number of atoms remains exactly the same. Key facts to remember. Atoms are never created during an ordinary chemical reaction. Atoms are never destroyed during an ordinary chemical reaction. Chemical reactions only rearrange atoms. The total mass before the reaction is equal to the total mass after the reaction. The law of conservation of mass is true for every ordinary chemical reaction. Question: what does the law of conservation of mass state? During a chemical reaction, no atoms are created and no atoms are destroyed. Because the number of atoms stays the same, the total mass of the reactants is always equal to the total mass of the products. Question: why does the total mass stay the same during a chemical reaction? The total mass stays the same because atoms are only rearranged. No atoms are created and no atoms are destroyed. Question: what is a reactant? A reactant is a substance that is present before a chemical reaction begins and takes part in the reaction. Question: what is a product? A product is a new substance that is formed when a chemical reaction has finished. Question: if a reaction changes the color and appearance of a substance, does this mean that mass has changed? No. The appearance of the substances may change completely, but the total mass remains the same, because the atoms are only rearranged.